Yeah, welcome to Zero Networks again. Right now, we are about to deploy solar energy solution to this particular client, and he's a returning client. We did something like this for him in his former house, and here, this is a new house. Ignore the background. There's a lot of work going on. I think the developers want to deliver this house this week, so you have a lot of work going on. They're doing carports and everything. But the client called us, Zurian, we like what you did before, and he's a subscriber, so what are you doing not subscribing to our channel? So he called, come back and do this installation. So this beautiful edifice, I'll take you around so you can see how it goes, see all the structures. But luckily, this is the house we will be doing the work, and definitely we're installing 40 pieces of 620 watts Longi solar panel. So do the maths. You see how many energy we are about to harness. So let me show you what we have here on ground. Come follow me. Yeah. Paul, how are you? Well done. So, like I said, we have a lot to do here. This is the house. This particular house is our house of interest. A beautiful edifice. See the building and everything. So we brought this, first of all, this is the solar panel we are using. Longi, 620 watt Longi. They call it Hymo X6 Max. So this pallet contains 36 pieces, but we are installing 40. This is the remaining extra 4 to add to the one full pallet, and this is what it looks like. So for the NEPA input, this is where everything starts, but this system will mostly be kind of off-grid. We only use NEPA when the weather is too down or the battery runs out. But believe me, I'll show you the batteries we're about to install. Everything, it's wonderful and top-notch brand. Of course, it's there again. So let me show you the rails. And on the previous video, some people say I was too fast, so I did not pay attention. I did not. Some people say I was too fast. I did not carry them along. I was too fast. I did not take time to explain everything. So right now, I'm going to explain that. So first of all, this is the aluminum rails we are using. The standard aluminum rails. Some of the team are on top of the roof already. You can see they're working, and this is the accessories. This is what it looks like. So this is the L foot that you mount on the roof. This is what we handle. This is where the rest. All these are L foots. Then these are the clamps. So this follows as a part of the mounting accessories. So this is the mid clamp. Why we call it mid clamp is it's in between the panels. So at the end of the panels, these are mid clamps. Where are the end clamps? Oh, okay. So at the end of the panel, this is called end clamp or E clamp. E stands for end. So at the end of the panel, when there is no other panel, you put this at the end of each panel. So like I said, 40 pieces of 620 watts Longi solar panel. Do the maths. The calculation is on the screen. You see the total energy we are generating. So these are the spacers used to join each of the rails. So it acts like earthing. When we are earthing the rails, you get to see all of them. So that is it. And we have carried a whole lot. This is what you drill to the ground. And I forgot to show you something. Look at this. This comes with a rubber insulator that melts with time if the heat is much. So definitely this guarantees that there's no leak on your roof. Even this has the same little rubber that melts with heat, just to make sure that it covers whatever spare holes that will cause water to leak. So these things are watertight. And if your installer is not using this for your roof, please demand that this be used. And let's go up. Like I said, it's a wonderful house. You get to see what we have. Then I forgot to show you something. Yeah, those are the TUV 6mm solar cables we'll be using. They are TUV, high voltage, temperature resistance, ultraviolet resistance, 6mm. Most times I do put this thing under fire, set it under fire. A small portion, like 5 minutes, but we don't have time now. We are trying to run and meet against time. So most times I set it under fire just to prove. So it can withstand direct fire for 5 minutes. I don't know what sun temperature. We are in Nigeria right now, and the temperature is like almost 32 degrees. But I don't know if it's ever in any place get to 80. Not to talk of burning this under direct sun fire. So let's go. So follow me. Let me show you where. So this is a wonderful house. It's already set up. There's no light right now. That is why we are here, to set up and give light. So it might be very dark, but believe me, once we are done, you'll see this darkness no more. So follow us. Our work here is in 2 days. We'll bring up this place. We'll bring it alive with light and everything. It has a lift, but we couldn't use the lift because there's no light. We're still working on it. Okay, this way. So this is what we are installing. This is what we are installing today. Ignore all these materials. My people on the roof will go up there and see what they are doing. So let's start with this. Day is day again. I like using day. So this is day 16 kilowatt single phase. One piece. Then we have day. This is a battery combiner box, the new product we have got. So this is the RWF16 16 kilowatt lithium battery. There 16 kilowatt lithium battery, and this is what it looks like when it's out of the carton. So we have 4 pieces of this. 1, 2, 3, 4. So 16 kilowatts hour times 4. If you do the math, it's actually on the screen. So you see the backup energy that we have. But the customer was like, oh, this is my master bedroom. And this being my master bedroom, I want to monitor everything. I want the inverter close to my room. So this veranda, he picked this place where all the inverters will be. So this small glass cubicle was designed by the owner. I was like, this is too much, Zurian, this is what I want. And does it affect us? No. We have enough ventilation. Here will be very open. And we have like 20 cm clearance on the floor so that air can, pass through as well. If you know your thermal physics, hot air goes up, cool air comes under. Like I said, it's a technical person. So in no time, this is where we will utilize to set up the inverter system. So everything you need will be here. We'll have 4 batteries here. We'll have the 16 kilowatts here. And we'll have the safety boxes for both grid inputs, DC input from the solar panel, battery combiner box. And here, this is where the trunk, where we have all our inputs and outputs. The electrician in charge of the house has handled the wiring, has given us all the line, hot wires. These are outputs, and this will be the inputs to the inverter. So this is what we will do in no time, and I believe you enjoy it. Sorry, it's quite hot here, and I sweat a lot, but that's by the way. So this is it. Right now, the stage we are in now, we are installing the solar panels. So my people are laying the rails, just like you can see on our aerial view. But let's go up and see what they do, how those aluminum solar rails are being installed. So follow me. So this is to show you people briefly how we drill the L foot. Can I see? So this is the insulation, and is on top here. Your water flows down here. So easy, and that way you have your L foots, and that is how you lay all of them. See all the rails we have put for 40 panels, and another team that are locking down the rails. So you can see it's simple, And this is from start to finish. Over. So this is how many it is?
Shadow.
Align now.
I just try and then adjust.
Now the job be that.
First of all, this don't align with this one.
Don't forget, just okay.
Made it like this.
Yeah, make it the ground, the lowest of that adjustment.
No, not
You know it,
the adjustment will be this half for this line.
no go. That will come up. No, we never tie now. We are tying up. We are done laying the panels. So we are connecting 620-watt panels in series. It's a high voltage inverter with the max VOC of 500 watts. That's open voltage maximum you can take, 500 watts. So this is 8 in series. So we are doing the final termination on top of the roof. And I always discourage people joining the wire with sellotape and whatever. Ignore the background. We are up and it's time for prayers, but that's fine. So this is how to connect your MC4 connector. For this is the negative of the panel of the series, the end of the series. So at the far extreme, there is the positive terminal. So this negative and the other positive this is for the 8 panels in series. So we want to terminate this. For you to do that, you get an MC for the male that will enter here to complete the circuit. So you crimp it. I have it out here already. So it's just a simple process. First of all, lose it, feed the end strap through the cable. We are using a 6 mm like I told you from earlier. So you fix it. You cut 1 inch of your cable. Now, this is the cable we have. This is the conductor, the MC4 conductor. You push it in. And this is my crimper. So this crimper, MC4 crimper, has a 2.5 mm, 4.0 mm, and 6.0. The cable we are using is 6.0. So you put it on the 6.0. It's very, very late in the evening. So virtually there's no power here. So you lock it and crimp. And you see, very, very tight and strong. So this will give you a very strong connection. It doesn't stop there. You push it in back. Push all those places to hold the cable in place. And simple, you lock till it's very tight. So you have a very wonderful and nice crimp. So what are we doing? Let's connect to the panel. You get a snappy noise. You're good. You push it under. So we are done. We have connected, we have terminated here, and it's very fast. Using MC4 connector can be very, very fast if you know what exactly you're doing. Yeah. 40 pieces of 620 watt solar panel. Okay, today is the day 2 of our installation. Yesterday, we're done. Day 1 was to install all the solar panels, 40 pieces of 620 watt Longi solar panel. So done and dusted. You saw the video, and I took you every process, even what we used, the materials we used, and how to install them. So because I know the former video, people say I was too fast, I didn't show everything, I didn't really explain everything, but today it will be detailed and we'll explain everything. So now we are in the indoor. This is where the client choose for us to mount. And like I said, this is all what we'll be installing. The inverter, 4 pieces of 16 kilowatts day battery. And ignore the side, these are just our tools and machines we use for installation. So come and see, one battery is here already. So we are using it for measurements. It is a very nice glass cubicle, but has enough ventilation. So in no time, all this, the inverter from my drawings, I don't have the drawing here, but I did a drawing. We took measurements of the space. So aesthetics matters as well. Yeah, making it look nice in the eyes. So the inverter will be here from the drawing. Then the DC control box will be here. Then the AC control box will be here. We'll try a way to mount the batteries here. This space cannot take 3 batteries standing, so we'll look for a way. At the end, you drop your comments whether you like how we finally resolved how to mount this. Then this is the input and output AC line. So in no time, we'll get busy and stack everything here and do our connections. And at the end of today, we should commission this place and hand it over to the client. So just watch. If I keep 4 feet, that's half of the battery. You will shift out when they just shift up. Bring another of this. Then from there, mark 18. Wait, mark 18. 18 is there. Where we want it to show, it's 8, or call it 9. So this plus 9, 24. Call it 3 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this extra 4. So 4 feet is fine. So that ruler, give me that ruler. I carry one. Okay, it's there. Where's the pen? Bring level. Pen. Okay. Plumb again. Yeah. How we go take carry this battery for this side? So this is the line bar, and this is where our 18 stop. Yeah, what? If you just pause that shot. course. Okay. Sure. Okay. Yeah. Okay. Use my Samara. Okay, so now we are done with mounting everything. Like I said, you see how this place has transformed. So the inverter, this box, it's for the solar control, solar switch. And this is the battery bus bar. You can see the inside. 4 batteries, but this can carry 8 of those batteries. So you can see 1, 2, 3, 4. Then there's another control box here, strictly for the AC output and input control. And that is it. So now we are done with mounting all what we need to mount. The next thing is putting all the accessories and terminations. So I'll be explaining each terminations we'll make. So just watch, stay tuned. Hmm? Okay, so now that we are done with fixing and mounting all the batteries, the boxes, the inverter in place, then we are done with the physical work. We're about to start termination of all those, and I'll let I'll carry you through all the process. So let us start by showing you what we have here. These are from the solar panels that we did yesterday on the roof. So we have 10 cables here, 5 positive, 5 negative, each string. So we have 5 strings. Each string has 8 620-watt panels in series. So this is for the solar control box. So we'll start populating it, then we'll start terminating, then we'll connect it. Now I've opened the inverter. So all this is the MPPT. If you're familiar with there, a brief explanation. So this is MPPT. You can see it has 3 MPPT. That's maximum power point tracker. So it has 3 MPPT. This has two battery input terminal because it's 16 kilowatts. And this is your generator. For this case, this installation, we are not using generator because the client is not even ready to get a generator. So this is your output to the house. Remember, it's a single phase, and this is where you'll be connecting your grid power if you need to charge it, but you can actually go off grid with 40 panels. I think we are good to go. So let's populate this breaker box with all the safety breakers and surge protectors, and so this is a Kini box. I like their product, so I got Kini breakers, DC breaker. So this is I think the open current for the panel is like 15 amps. So this is a Kini 25 amps DC breaker. So for this case, we'll be using 5 of this, 1 for each string. So let's populate them. So in this design, I will have 2 strings up. I should actually have so 5 of them. We are done with the breakers, but now DC surge protectors, and this will only work if you have a very active earthing system. So each of the strings will have one. Because we don't actually joke with protection, so we'll make sure we'll put this in each of the strings, and so now let's move here. This is the AC side, that was DC. So this is where the grid inputs to the inverter will be controlled. I always put a bypass changeover so that peradventure this inverter is faulty, the whole load connected to it, people will not be in darkness. So you can actually flip it to bypass the inverter till we come for maintenance. So we'll populate this side too. And this is a 125 amps MCB changeover. And let's populate this box too. And 125 amps input breaker. So this will stand between the grid and the input of the inverter. Also, AC surge protector. Just another protection layer. So this is another breaker for the outputs, to control the outputs. So this is what we have here, and this is what we have here. And the next stage is your, so this is all what we'll be connecting in no time. This is your battery bus bar. So all those 4 batteries is coming here. Each of those is a 250 amps breaker, DC breaker, 250, 250. So this is for the 4 batteries. We have a heavy bus bar here, almost 600, more than 600 amps. This is a very thick one. So that is it. So in no time, we'll be doing all those connections. Then we'll terminate everything here and commission the system by doing the final configuration, setting the time, the date, the battery charging, and everything we need to set here. So follow me as we connect. Huh? 3, ba? 3. Okay. Can go back to your. Sharp up. This yeah. Hmm? They should sharp, huh? Okay, so I just created the holes for the MPPT. So those were our communication and earthing cable, the 3 MPPT, then inputs, and output, that's grid and load. So we have perforated all this. It's time to start connecting. Okay, so this is a 4 earthing cable. So for this your surge protector to work very well, these are the green devices here. They come in different colors depending on the brand you buy. But for those things to work very well, you have to have a very, very sound and smart earthing system. So, and I'm using a 4 earthing cable to connect. So come closer. So as you can see, it has a DC positive, DC negative, and potential earth. So without a good earthing system, this thing is just like you're just putting popcorn just for fun. So, and this is our positive terminals. All to the right are positive terminals for the 5 strings, and the left is our negative terminals. So you have to connect positive to DC positive, negative to DC negative, then those to the earth. So I'm about to connect the earthing for all of them right now, and we'll take it from there. Ignore the background. Like I said, the site is ongoing. A lot of people are working at the same time. But some people wonder, why am I using black cables all through? No, it's not that black. This is a true black. The inner insulator is black. So when you peel it, you get to see black. It's a TUV cable to withstand high temperature, high voltage. So you see, the inner is black, showing well, but this is black and red inside. So if I peel it, you see that the inner is red. So that's how we know our positive and negative. So don't get it twisted that we are using the same color code. It's red inside. So once I look at the front, I know which is positive and which is negative. So let's connect the output from here. We'll connect it straight to the inverter, and we are done with this box. We'll cover it. That's how we'll be progressing from one box to the other till we set up and commission the system. So all our 5 strings, panels all here, 5 strings, 5 such protectors for each string, and 5 25 amps DC breakers. So now we are done here. Both the input from the panel and the output from this breaker, it's coming to this inverter part. So we are done here. Like I said, we'll be installing and terminating box after box. So we are done with the solar DC box. So it's about we're about to cover it and move to the next box. So now we are done. We are moving to the SC panel, but before then we need to terminate these solar cables. Like I said, ignore the background. We're still at site, so there are a lot of people working. So this is your current transformer that will be clamped to the positive inputs of the grid. But I want to connect this. You can, there's no law way to keep it, but I like putting it inside the inverter. You can draw it to wherever you want as far as it meets the condition. It's being clipped to the positive line of the grid. But I want to connect this. So these are our terminals for different things, but meter and everything. But for CT, that's current transformer, the white is number 5, and the black is number 6. So this is 1, 2, 3, 4, 5. 5 is written. You push this down and insert it. It will go straight. You release it, and you can see it's firm. And black is number 6. So that's the next number there. So you push, you do the same thing, push it in, and release. You can see it's very firm. So I'll just manage it down here. This is how I like connecting my own CT. You can see all the solar inputs have been connected and very firm and tight. You can see I'm putting a little pressure on them and they are all fine. We have connected our earth. This is our earth connected to the earth terminal. So the system is properly earthed. So this is BMS to connect so the inverter can communicate with all these batteries. So you see how neatly we pass all our cables here. We'll do the same, but I want to show you how to connect your BMS. Then there's this ferrite core. Its work is mostly to reduce interference. So you fish it there. You turn it 2 times. If you read your manual, they'll tell you exactly to do the same thing. This is 1. You turn it the second time. 2. So now it's properly fixed. And this is your BMS port, BMS CAN ports. So you click it here. Then here will find its way through this route down to our battery combiner box, then down to the primary battery. So in this case, I intend to use this battery as our primary battery, where every other battery will take communication from. So we are done connecting the BMS. Now we are done connecting the load outputs, and we are done connecting the grid inputs. You can see the current transformer here, and everything is well arranged. and all those inputs, outputs, and all those will be terminated. But we want to leave here because I want to move fast and cover this. But one thing it's remaining, it's the battery. So we need to connect the battery to the bus bar where all the batteries will take from. So to do that, these are 50 mm. You can see 50 mm square DC cable. So two positive, 50-50, two negative, 50-50. So automatically we are doing 100 mm so that it can carry the current this can do. So let's go and crimp, and this is the 50 mm cable lock. So I'll show you how to crimp and lock this to be very tight and firm. So let's go. So to crimp those four wires, we'll be using those hydraulic crimper. This is from 10 mm to 120 mm. So uh, gonna check. Okay. So okay, the last thing I crimped was 50. So you see the 50 mm here, 50, 50. So no need to change the block. So we'll just move ahead and start crimping. So let me crimp the first one, then others will do the same. So I've actually locked it here. Put our cable, and the greatest problem here is holding it to place. Yeah. So we are we are connecting batteries now. Ignore the background. Other people are working. I'm not the only one working on the site. So now, earthing of the battery. This is a Solocom earth cable from there. So we'll pass it. All the earthing will happen at the battery bus bar as well. So we'll pass it through the trunk. That is settled. This is the BMS cable. Complete. This is the BMS cable from the inverter. So this is the primary battery. So we'll now put it in PCS. PCS. So it will control. So the rest will take it out from here. So now I want to start putting the battery cables. So this for battery one. Yo, so so we are done here. battery terminals connected. So altogether 50-50 mm. So 100 positive, 100 everything connected, BMS cable connected, solar connected, city transformer connected. So everything here, we are done with the connections here. It's just for us to turn it. But before I cover, I'll turn on this 200 amps breaker for battery inbuilt, and we'll cover. Then we complete the what next? We'll complete the battery bus bar, and we commission the system. Okay, so this is how we wired our AC box. Uh, so this is the cover. So grid input, inverter bypass, inverter output, and control box. So this is how we wired it. So this is the input from the grid, NEPA, live and positive and negative. Like I said, the electrician that wired we have just grab the cable for us. So yeah, he did the using the same color, but that's by the way. So live and negative, it comes into this 125 amps breaker, and this goes to the inverter. So this is the feed to the inverter. But before coming to the inverter, it passes through this surge protector, both live and negative, to protect it. And now this is the output of the inverter, the control output for the inverter, and it comes out from the inverter down here. This is an MCB changeover. So if you take it down here, it's an inverter. If you take it up here, you bypass the inverter straight to this input, so it will behave as if inverter never existed. So this is used for emergency if the inverter, parameter the inverter is faulty. That is how why we introduced this. And it's just a simple electrical wiring actually. And remember, it's earthed as well. And that is what we have in the box. So we'll cover the box now and you'll see. We'll cover and label it as well. We have terminated the batteries, all the batteries through the battery combiner box. We have handled the AC just in and out, the AC, so all the wires you saw here have all disappeared. So before we cover this, we need to check our communication. So I want to power this inverter, and powering it, I'll start with one battery. I'll take it closer to the screen. This thing is a little bit high, so I'll need a ladder. So I'll take it to the screen to see the basic configuration. I will still adopt it. I will go on Solarman business, so you can still monitor the system. You can monitor it online because of this. This is a Wi-Fi dongle. So let's start by turning on this first battery. This is, like I said, this is the primary battery. That is why you have the communication cable coming to this PC. So out to the second battery, in, and that is what we'll do. So we adopting this battery and connecting the communication cable. We'll start by powering the inverter, but before then, I'll power the primary battery, push it on, and turn on the battery. You can see this particular battery is at 50%. This day, a 16 kilowatt has only this screen, and the rest of what you can monitor, it will be on the app on your phone. So now that this first battery is up, I'll turn on the inverter here. Once you see this blue ring light, we are set, but this will take a little bit because this is the first time we're turning on this inverter. So yeah, the screen is up. So I'll need to climb something so you can see, and we'll start the basic configuration. It's on. Yeah. So now that we have set up everything, our inverter is on. So the first you will do is to set the date. So setting the date, will come to basic settings. And sorry, the glass, a lot of reflections. So I just hope you see what we're doing. So I go to 2025, and today's date is 9, right? The month of September, which is 9. So we'll go to 9, and today's date is 9, and we'll choose 24 hours and accept. Check it back again. The language is English. So 999, and we're using 24 hours accepted. So if we come here, you can see it has peaked Tuesday. Today is Tuesday actually, and oh, I didn't set the time. So I go back, basic. I did not set the time. So right now it's 17 hours of 17. I wish these reflections are less. 17, then 27. Oh God. 17, then 27. Now we're good. So that is the basic settings. So you can see Tuesday, the new data has picked up. And the next thing we're going into another settings. We'll go to battery settings. So right now I will instruct, let's see the settings we have here. And cancel. So battery settings. Now we're using lithium battery. So I'll instruct this to use lithium battery. And that is it. Let's see. There's something I like confirming. Now it's showing you day battery. And by default, because of the communication cable on the primary battery, it has seen day, and this battery, don't take it too much. This battery has a charge and discharge current of 160 amps. So immediately you pick the lithium battery, the BMS will set in and give you all those basic settings. So you can see 160, and right now state of health is 100. The next thing I want to do is to adopt a new battery. So the more I turn on the second battery, you notice that those figures will change. So watch out for those figures. So right now I'm powering the second, you don't need to show. I'm powering the second battery, comes in and in, and it comes in and out. So right now, I just powered the second battery. So let's give it, wait for a while. You notice those figures will change. That is how you know that your battery communication is working. So if you notice, it has changed to 320 amps and 320 charge and discharge. That is the recommended. So the BMS will be playing with it. I wish this thing is very bright, but there's nothing we can do here. It's a little bit outside, and there's a lot of glass reflection. So our two batteries are working very well. So what I will do, I'll keep on turning on. So I call it adopting the battery till I turn on the fourth battery. You now see that all it will pick on its own. The more I turn on for the first time, all those figures will keep going on its own. Just stay on the screen while I add the third battery, and so I'll just turn on the third battery now. Let's watch, give it a while. You can give it a while, reduce it a bit. And you see it has increased to 480 amps. So that tells us that the three batteries are working. So I'll turn on the fourth battery so you know what we have. But you can override those BMS settings by setting your own maximum uh, charge and discharge currents, of which for me I will just do. I always like taking it 200 amps to control. So I'm about to turn on the fourth battery, out and in, and I turn it on. So let's check. What it was 480 before. So you can see 640. So all the four batteries are on now and they are working. And from the their BMS, you can see all the settings. So let's go back and check our battery settings again. So here, I'll okay, so as you can see, I want to set it, not the other what the BMS showed. I was just letting you know how to, you know that your battery, your BMS that have acknowledged that you have added more than one battery. So the battery capacity of this 16 kilowatt hour there battery is 314 amp hour. So now we have four pieces of this. So 314 times 4 will give us 1256. So I'll keep taking it till let's see the highest this have. Let's still going. 1000 watts. 1000 watts.
1256.
1256. If you do your maths, that is it. And I will leave the max charging current to be 200 for now. $200 amps, and max discharge, I'll leave it at 200 as well. But let me just see what the max for the system is. Just playing with it, we're just having fun. It's 290 actually for the system, but I'll leave it at 200. Max discharge, I'll leave it at 200 too, so that we know that we are having 50 amps for each battery. So same thing with charge. Okay, so I'll accept this back. So you can see my settings has been set. So I don't want, there's no generator, so I'll turn off this and grid signal, grid charge. Yeah, I don't want to use too much energy to charge from this, so I'll reduce it to only 100 amps, but the solar panel can hit the 200 amps that I set. So I'll leave it at 100 amps. And yeah, so that is it for battery settings. And you can see there, so shutdown, I don't want to touch this. Shutdown 20%, low battery 35, restart 50. So this is fine by me. Escape, this is fine by me. But there's another settings I like to do, so I call it system work mode. I want to prioritize. So first of all, we set zero export to load, so this inverter will not give out light to the grid actually. And then outside this, I go here. I like using this period because it's very sunny here. The center it now. Ignore this, just center it at the middle. It's very sunny here, so I like using this time of usage and no generator. So I want it to be working. Grid will charge from 1 to 5 a.m. and from 5 a.m. to 9, I want the battery to run. Okay, charge till 9 o'clock in the morning, but the rest from 9 till 1, from 9, call it from 9 a.m. till 5 p.m. That is when solar will handle it. So that is the settings I like to set. And there's not too much to the settings. These are just the the basic settings. So all the settings will work for Monday, Tuesday, Wednesday, Thursday, Friday. So now we have our system all set on. So next thing we'll do now is to turn this on. So we'll check what we generate from. So this turns on the solar panel. So this is a DC switch, the switch between the solar panel and the inverter, but I like using this. So what we did, I'll turn it on and we can see that energy has started coming in. PV1 is on. So I'll turn all of them on, turn all of them on, and turn all of them on, and wait for all of them to peak. And wow, all of a sudden, this is what's the time now? This is 5:30 in the evening, getting to 6 o'clock, and we already have 3,000 watts from the solar panel. Can you zoom in and so they can see what we have? Yeah, sorry about the shadow. It's a glass house where we have the inverter. So far so good. We have 3,580 because the battery itself has started charging. So let me go back to the default screen. You can see, and that is all. So here will remain permanently on. Here will remain permanently on unless we have reasons to come and do maintenance. So what is left is for us to cover here and cover all those batteries and do uh, cable management to hide most of the cables. I don't like seeing cables, and I don't think anybody will like seeing cables jump around. So we do that. Then the next thing is for us to use a machine, labeling machine, to label everything. So we know everywhere here, but the client, the owner of the building, may not know. So we need to label this box and what to do. We need to label the SC box. This is battery combiner box. We need to label this battery. We need to label master and every other thing. But right now the system is up and running.